Hi, this is my first stream at the beginning of the semester, so my question is, can you hear me? Okay, so maybe my connection is a bit better now. So I'm going to start my presentation for now. I'm experiencing some network issues. I don't really know why. So thank you. Yeah, it's a bit laggy, but maybe it's going to be better a bit. So for today, I'm going to talk about history of computers, and that's why I have my website in here. I wanted to show you. Here it is. So let me start. At the same time, I'm going to check the live feed on my phone as well, whether it's working or not. Okay, and I'm going to have a conversation on chat if you have any questions. So today's topic is history of computers, and we are starting from the 30s. We are in the 20th century, in the times when there were no computers yet. So first of all, I'm going to present how the evolution happened and how did we get to nowadays where we have computers surrounding us, where we have computers being carried in our palms and so on. So the first invention, one of the first inventions that led to today's computers was the telex machine. Telex machine is a machine that is still in use, but not one that you can see on the picture. And this machine served as a tool, as a gadget of delivering information on long distances using phone lines. So telex was able to connect remote regions of developing world, thus contributing to economical development as well. Going back to the 30s, and we are in the year 1934, where Paul Otley, a Belgian inventor, information scientist, one would say, imagined a project somewhere at the start of the century called Mundaneum. Mundaneum was a kind of device that combined enhanced card catalogs with 16 million entries, photos, documents, microfilms, and more. And his general idea was to build a library where he will be able to gather the knowledge and link that knowledge together, so others they can somehow reach it. I see that my students are logging in, so I would say welcome. Very nice to have you in here. Good morning. This class is about history of computers, and those who haven't been at the first week in here, we are going to go through the different phases and history of computers and get to present. We are not only going to talk about machines, rather about software, about ideas, visions, and so on. So here is a vision for you. American scientist Vannevar Bush, he did some research in physics. He visioned a machine called Memex, which was supposed to connect most of the knowledge using hyperlinks, something that's popular nowadays, but in 1930s this wasn't the case. He imagined a machine called Memex which would store knowledge, and trailblazers, like a profession, trailblazers would find the links, and they would connect those links, thus the documents would be interlinked as well. You can imagine that that time he didn't have the technology to do so, but nevertheless he was one of the pioneers of internet. As you can see, not every year we had we new inventions, but just to demonstrate how the technology developed, here we have a Model K, which was built in Bell Laboratories by George Stibitz using relays. It was kind of a complex calculator, but you can see that it missed both screen, display, and keyboard as well. The same year in Germany, a fellow engineer, Konrad Zuse, built a computer, Z2, also using telephone company relays, but later, as we can see, the Z3 and Z4 models, they already featured a bit newer and more advanced technology. End of the 90s, beginning of the Second World War, we are getting to a World's Fair where one of the first robots was introduced, and this robot, as you can see on the image, is a kind of android which has got a robot dog as well. He responded to the rhythm of voice commands and delivered wisecracks pre-recorded on record. So basically he couldn't do anything, it didn't have any real sensors, but still it looked as he was able to communicate in the way, and it could move its head and arms. So the general idea was somehow to imitate a living man, a person. History of computers is related to to several developments and companies. And these companies included Hewlett Packard, David Packard and Bill Hewlett. They founded a company in Palo Alto in California in a garage. The same was done by several people, Bill Gates, Steve Jobs, for example. And they made an HP 200A audio oscillator. It rapidly became a popular piece of test equipment for engineers, and Walt Disney Pictures ordered 8 of these models to test recording equipment in several theaters. So as you can see, it all began with different electronics. We are moving to the 40s now. We are in 1940, where a quite sophisticated number calculator, CNC, was completed by Telephone Laboratories, designed also by George Stibitz. And this calculator was demonstrated at American Mathematical Society conference at Dartmouth College. This is the college which is famous for artificial intelligence research and studies. So as you can see, in some 60 years, 65 years, there is going to be an AR seminar where they will discuss the use and idea of artificial intelligence. The year is 1941, where Konrad Zuse just finished his Z3 computer, still using relays, actually 2,300 of them, and it was used for aerodynamic calculations, but it was destroyed in bombing of Berlin. But he reconstructed his machine in the 60s, and it's currently on display in Deutsches Museum in Munich. So I don't think there is anyone who hasn't heard about Isaac Asimov and 3 laws of robotics, which was published in the May issue of Astounding Science Fiction. These laws are as follows: a robot may not injure a human being or through inaction allow a human being to come to harm. A robot must obey the orders given by its human beings except where such orders would conflict with the first law. And the third one is, robot must protect its own existence as long as such protection does not conflict with the first or second law. So this was the first time where he coined the term robotics. I just switched to a mode where we will be able to speak more about robotics. As you can see, there are several timelines in here, but let's just switch back. And let me show you an electromechanical decrypting device. So basically, electromechanical computers, they were built even in the 40s, and from the 50s, basically all the computers, they were only electronic ones. We are in the year 1942, and here we see maybe one of the first computers that actually worked. This is not a genuine genuine electronic computer. Rather, it's a kind of experiment which worked. The Atanasov Berry computer, John Vincent Atanasov was a professor at Iowa State College, and his graduate student Clifford Berry helped him build a machine. They worked some 3 years, and they had a patent dispute related to the invention of the computer, which was resolved in 1973, so it took almost 30 years, when it was shown that the ENIAC co-designer John McCauley had seen the ABC shortly after it became functional. So basically this was the first computer and not the one that was designed by John von Neumann, Hungarian Neumann János, who went to America and there designed computers, and John Moseley, who was actually an engineer who built one. So this computer was built as a replica in 1997, and it was proved that the machine functioned as Atanasov had claimed. The replica is the one that can be seen in Computer History Museum. If you can find the time and after the pandemic, maybe it's worth of going there. Moving through the time, showing, for example, how a step drum calculator was designed. It was the first smallest all-mechanical 4-function calculator ever built. Or, for example, the Bell Laboratories built a relay interpolator. It was programmable by a paper tape. Later, at the end of the war, we can see the first Colossus operational. It was designed to break a complex cipher used by the Germans in the Second World War, and it was built around 2,500 vacuum tubes. It's interesting that a series of pulleys transported continuous rolls of punched paper containing possible solutions to a particular code. And Colossus was such a smart machine that it was able to break the messages in order of hours and not weeks. So during the war, you can see how time really mattered. And it's really interesting to see that the machine's existence was not made public until the 1970s. This was an act of disinformation, so the enemy wouldn't know a machine like that existed. Conceived by Harvard physics professor Howard Aiken, designed, built by IBM, the Harvard Mark was one of the huge computers. It was room-sized, relay-based, so it didn't have vacuum tubes. It still had relays. It produced mathematical tables, and soon it was superseded by electronic stored program computers. But at the time, it was one of the most advanced machines. A weight of a computer that time was around 30 tons, which is a huge number. Here you can see a Hungarian inventor, mathematician, John von Neumann, who wrote a paper, first draft of a report on EDVAC, and this was the first idea of modern computer. The paper was circulated widely. His intention was to get as much people as possible acquainted with the idea of a modern computer, and it had electronic storage of programming information and data. So before his time, no one thought that it would be possible to store data and the program at the same space. This helped eliminate clumsy methods of programming such as plug cards. Here at one of my books you can see a restructured plug card, for example, punch card. This is a punch card. You had plug boards as well, or simply you had some paper tapes. In Hungary, first computers used X-ray film boards cut in half, so they were basically kind of punch cards as well. Hungarian-born von Neumann János, he was a prodigy in hydrodynamics, ballistics, meteorology, game theory, statistics, and he concentrated his work on Princeton in Princeton's Institute for Advanced Studies. Speaking about programming languages, Konrad Zuse, the one who developed several computers, he started working on Plancalcul, the first algorithmic programming language, which goal was creating the theoretical preconditions for the solution of general problems. As you can see, that time, people working with computers, computer scientists, maybe engineers, they did everything from designing the computers to working as support staff to their own computers, to writing programming languages, programming the same computers, working in maintenance and so on. So not as nowadays where we have different people for different tasks. That time computers, they actually depended on one man, and that man was inventor, a coder, he was a mechanic, and so on. Just for fun, a fun fact, the first actual case of bug being found was thanks to Harvard Mark II computer, and the COBOL language, a standard and widely adopted programming language that transformed the way software was developed for business applications, was developed also in the year 1945. Programming languages is still in use today. Here is the MEMEX concept. We talked a bit, or at least a glanced at the ideas of Vannevar Bush, who actually published his concept of MEMEX in the Atlantic Monthly and Life magazine. His idea was a kind of genius one, where two tablets would serve on a desk, and microfilms, thus the information recorded on microfilms would be accessible this way. So, going further in time, I think we are going to get to 1950s today. Moore School Lecture takes part. People from several research institutions from United States, France, UK, and Germany gathered. Advanced studies were held there. Among the lecturers were early computer designers like John von Neumann, Howard Aiken, who we just mentioned, at Harvard Mark I, or G. Presser, Eckert, John Mauchly, also working close to John von Neumann, mathematicians like George Stibitz. Students included future computing pioneers Claude Shannon, Jay Forrester. These free public set of lectures included the EDSAC, BINAC, later IS machine, clones like AVIDAC. So as you can see from lone wolves working as pioneers, there became computer schools where people would gather and share their knowledge. Here you can see an astonishing image of an even more astonishing machine called Whirlwind. You know, one that is like a cyclone. And the general idea was to be a computer that had a magnetic core memory and so on. And it worked for the purposes of flight simulators, where you could train bombers with them. Also, it would calculate ballistics and so on. The public unveiling of ENIAC, ADVAC and ENIAC, was made in 1946. The ENIAC was the later. And it was 1,000 times faster than the previous computers. Hence, the previous ones were electromechanicals, and this computer was completely electronical. It used panel-to-panel wiring and switches for programming, so it still wasn't working on the general idea of computers like John von Neumann imagined, but still it occupied more than 1,000 square feet and used about more than 18,000 vacuum tubes, and its weight was 30 tons. It was believed that ENIAC had done more calculations over the 10 years it was in operation than all humanity had until that time. Let me stop for a second. So, in 10 years, one machine in 1946, where we didn't have smartphones, hell, we didn't have any computers either, would do more calculations than the previous complete history of humanity had recorded. Just think about that. The year is 1947. It's 1947 where Manchester Mark I Williams Hilbert tube was introduced. It was the first high-speed, entirely electronic memory. It used a cathode ray tube, similar to those in old computers, to store bits as dots on the screen's surface. Each dot lasted a fraction of a second before fading, so the information was constantly refreshed. Information was read by a metal pickup plate that would detect a change in electrical charge. So as you can see, a new type of memory was developed that time. Cybernetics. The term cybernetics was coined by Norbert Wiener, who published the book Cybernetics. And the general idea of cybernetics is that this phenomena is related to artificial intelligence and control systems, something that Benninger wrote when he published his book on information management. And he coined the cybernetics, the term from the Greek word steersman, people who steer using the stars. The mathematical theory of communication was published by American mathematician Claude Shannon. This theory is not only used in communication, then it's used in information management as well. The general idea was to lay the groundwork for understanding the theoretical limits of communication between people and machines. However, you can use this theory to build a framework in case of communication between machines and machines as well. The first computer program to be run on a computer was developed in Manchester by Frederick Williams and Tom Kilburn and Geoff Toothill on a small experimental machine, small, I would say size of a closet, right? Which was called Manchester Baby. And this Manchester Baby was in function in 1948, and it was the first one to run a digital electronic stored program. Several companies like IBM introduced new computers. This one you can see, the SEC, produced the moon position tables used in early planning of the Apollo 12 moon landing. So that time computers, they had more or less one function to calculate. Nowadays they do the same, but using these calculations new virtual worlds are built. Our society is formed constantly. The algorithms that run behind social media, they influence people to not only to pay attention to the screen and social media, rather to somehow adjust their behavior as well. The year is 1949 and we are walking huge steps now. Alan Turing quoted by London Times on artificial intelligence. This is a historical moment because that time computers were nowhere near today's machines. What did they lack? They lacked a screen. They also worked without keyboards. They were nothing like today's computers, and no one could imagine if they could think. But Alan Turing said that I do not see why the machine, should not enter any of the fields normally covered by the human intellect and eventually compete on equal terms. I do not think that even draw the line about sonnets through the comparison is perhaps a little bit unfair, because a sonnet written by a machine will be better appreciated by another machine. As you can see, genuinely a true and new idea. The birth of the modem. Not long ago, in the beginning of the 40s, we had still electric machines, but here we now have I hope that we are back. I was experiencing some technical issues, but I can see that we are back. I'm checking myself on the smartphone whether the line is working and connection is not lost. So I was just talking about modems. The phrase itself comes from modulation and demodulation terms, which were somehow summarized. So modems will be adapted to computers in the 1950s for the upcoming SAGE system. The SAGE system was an air defense ground air missile system developed in the United States, and it had several bases around the country, so they needed phone lines to connect and to send information. The radio waves didn't do the thing, and later it was commercialized by Bell Telephone in 1958. Brain surgeons were quite interested in artificial intelligence studies because they thought that human brains and computer brains are similar, but a British brain surgeon stated that a machine is not able to think on its own or to feel. It cannot write a sonnet. The sonnet comes up, sonnet like a poem, right? Comes up again, not only in Alan Turing's work. So here we have a discourse, a strong conversation about artificial intelligence. Not only in United States, but in Australia as well, we have supercomputers, that time supercomputers, which are used in physics laboratories, industrial research, and so on. The first practical stored program computer to provide a regular computing service, EDSAC, was built in Cambridge University using vacuum tubes and mercury delay lines for memory. As you can see, new ways of building computers are just being invented. And the director was called Maurice Wilkes, whose idea grew out of Moore School lectures he had attended 3 years earlier. One of the major advances in programming was Wilkes' use of library of short programs called subroutines, stored on punched paper tapes and used for performing common repetitive calculations within a larger program. So you can see how algorithms are being developed, the new ideas are being implemented. IBM, a company that was established long before the Second World War and which had a huge impact on engineering and mechanics, said that it would replace all the moving parts within a decade. The change to electronic marked a major shift for IBM, since the 1920s was the world leader in electromechanical punch card systems, for example. Initially, electronics mean the use of vacuum tubes for circuitry, but in the 50s, they made a new equipment using transistors. So from the end of 50s, we can see how transistors are being introduced. Later microchips came, but the transistors, they were able to miniaturize different equipment to make it much, much smaller. Miniatures compared to huge room-sized equipment. Going further in development of memory, while working on the Whirlwind project at MIT, Jay Forrester, the one who attended Moore School, he wrote a notebook entry that describes his early thoughts on a coincident current technique for a magnetic core memory system. It was a first reliable high-speed random access memory for computers, or RAM. And the magnetic core memory was widely used as the main memory technology for computers well into the 1970s. So an idea upheld for some 30 years now. Wow. We would think that we jumped in time a lot, but actually we didn't. Built by a team of engineers, Mark I served as a prototype for Ferranti's first computer, the Ferranti Mark I. The Manchester Mark I used more than 1,300 vacuum tubes, and it occupied the size of a medium room, so it had to be cooled down because it generated a lot of heat. We are moving to 50s now. 50 as it is, 1950. One of the first commercially produced computers which could fit on a desk. Here we can see a quite massive desk where the computer is held, was the 1101 or 1101, and it stored 1 million bits on its magnetic drum. An experimental robot called LZ used photoelectric cells to seek moderate light while avoiding both strong light and darkness. And the next book published by Isaac Asimov was I, Robot. I think that you have all seen the movie which was made like 10 years ago, I, Robot, that was based on this book. Again, about memory, magnetic drum memory, as you can see. It helped store programs in a computer. It stored information on the outside of a rotating cylinder coated with ferromagnetic material, so iron, circled by read-write heads in fixed positions. In Britain, based on ideas from Alan Turing, Pilot AC computer National Physical Laboratory was built. This was one of the centers where ARPANET got its original idea. We shall talk about that later as well. The size of the machine was quite smaller. The design packed 800 vacuum tubes in a small, compact 12 square feet, which is a small size. The Hobbyist magazine Radio Electronics published Edmund Berkeley's design for Simon One Relay computer, and it could be built at home at the price of $600. Simon, the computer Simon, is so simple and so small in fact that it could be built to fill up less space than a grocery store box, about 4 cubic feet. So, as you can see, size is getting smaller and smaller. And the last date for today is 1951, where a machine, the Australian machine, placed Colonel Boogie March. Before that, not only that computer didn't have any screens, they didn't have any cameras, of course, no keyboard either, no video cards, hence no screens, right? But they couldn't play any music either. And this computer was able to do so. It was programmed to play several songs. The first commercial computer available for general purposes was Britain's Ferranti Mark I, and this was a refinement of experimental Manchester Baby, British government contract spurred its initial development, but the change in government led to a loss of funding. Second and only Mark I was sold at major loss to a university in Canada, Toronto. The UNIVAC 1 was delivered to US Census Bureau, so from that time they could do more statistical countings using computers. Modeled after the Cambridge University EDSEC computer, the president of Lions Tea and Company has the Leo built to solve problem with production schedules and delivers of cakes to the hundreds of Lyon's tea shops around England. So you can see how computers started to boost up the economy and solve real problems. Also, a computer called Nimrod was displayed at the Festival of Britain. This computer was able to play games. We can see a funny robot here, a robot squirrel, and our last entry for today is the Turing test. The Turing test that is supposed to answer the question, can machines think? But basically this test is only about the issue whether machines can communicate as humans and not think. So based on the written replies to the question, if it cannot be distinguished whether a human or a machine respondent is on the other side of the line, we must assume that that machine is thinking. Okay, so I think that because we are not in a classroom and it's much more difficult to have a class online. Next week's class, I hope, is going to be offline in the classroom. I suppose that we can round up and say that walking in giant steps, we went through the stuff and information we wanted. So for today, this would be my speech, and for next week, if nothing changes, we are going to meet in person. So just some final feedback, if you could please provide me. Was this class helpful? Was it difficult or easy to follow? And so on. Thank you. I can see that all of you were in the class, so if you have any questions, we can discuss that in a real environment as well, and I would be glad to meet you in person as well. So thank you so much for being here. See you next week. Thank you for your very kind replies. We are going to meet next week in person. Thank you very much.